Good evening, everyone. I'm here to present our project, and we've taken a topic as chest X-ray disease detection and classification. We've taken 4 different diseases, which is the pneumonia, bacterial, and viral, and we've taken COVID-19, and also we've taken healthy lungs in order for reference. I'm Vian Guncha, and I'm the project leader and tester.
Hello everyone, I am Aditya HMR and I am the data expert and designer. I determine the required data and I supervise what type of data is collected and if it's ethical, and I design the project flow. So this is our project plan. These are the dates that we met up to discuss upon our AI model and how we should design and train our basic AI model. And so the communication plan, we usually met online and we met twice a week to discuss about our AI model, and everyone contributed equally. We used tools like Microsoft, Google Drive, Google Meet in order to do our meetings and exchange our AI model and what work we have done on the AI.
So now problem definition. So our problems were lack of access to advanced healthcare tools and timely diagnosis in rural places and villages. Also high workload of healthcare professionals, which can lead to delayed and inaccurate diagnosis, and also limited awareness and resources of critical diseases like COVID-19 and pneumonia, and also overburdened healthcare systems, especially in rural and resource limited areas, as I mentioned earlier. Which of these issues matter to us? It was mainly the overburdened healthcare professionals and also delayed diagnosis, which can cause and harm to the patient's life. So in order to reduce that, we've taken this AI model. So our main issue that we're going to focus on will be reducing doctors' workload and improving diagnostic accuracy. So this is a problem statement. How might we develop an AI-based solution that automates the detection and classification of chest X-ray images to assist the doctors in diagnosing COVID-19, bacterial pneumonia, viral pneumonia, and healthy lungs, and thereby reducing the workload?
So in this part, we talk about the users. Who are the users? Where are they? How does it affect them? First, we come to the doctors and radiologists. The doctors and radiologists, without these AI models, usually they face overwhelming workloads as they have to manually read and analyze each X-ray image, and this becomes very tedious and they are usually victims of work overload and fatigue. So as a result, the patients do not get the best results and the best diagnosis, which in order can turn into a problem as they are not treated in the best manner, and they cause further problems by going and consulting other doctors who give their own opinions. Hospitals and clinics too have a system in which they work. If they are continuously clogged by inefficient doctors, then they would not have the smooth running and they could not treat a lot of patients in a single day or in a single month. So the public health systems too are directly affected by the decisions and the diagnoses of these doctors and the decisions made by the patients in order to take up the treatment or not. So to actually verify what type of problems on the ground level are faced by these doctors or the patients or even the hospital staff, I went and I actually conducted a few interviews of the doctors and radiologists in the hospital, and these are the questions I asked them and these are the responses of the doctors, which you can see on the slide. And so usually we came up with, as I discussed earlier, we came up with the usual complaints of doctors of excessive workload and fatigue and lack of work on their best abilities, and the users are usually panicking and they are not waiting for the doctor's diagnosis, or they are blindly believing the doctor's diagnosis sometimes, which causes further problems as they are not met with the perfect treatment that can benefit them or save them from some life-threatening situations. So usually they would collect and prepare X-ray images, analyze them, and then report the result, which would then lead to treatment. But this is not being done efficiently, and hence the challenges faced by the doctors. So, and then we came up with a few ideas in the brainstorming slide, which Vian will now explain.
So in brainstorming, we came up with 5 ideas. First, the chest X-ray disease detection, AI-powered automated report generation, predictive analysis for early disease detection, AI-enhanced X-ray quality improvement, and integration with electronic health records for comprehensive diagnosis. So based on the 5 AI ideas we came up with, we made a priority grid, giving each of these ideas a specific parameter and points. So based on this grid, we found out that AI chest disease detection had the highest priority. So based on this, we found out that it is very high value for all the users and it's very feasible for implementing, and it also had a major impact on the workflow of the healthcare systems and doctors. Now, coming to the design, Aditya was going to explain that.
Okay. Now, after all these slides, we ultimately had to land on the design. So, in the design subtopic, I'm going to explain how we designed our AI model. First, usually in our AI model, we would upload the X-ray image, and this AI model would classify this into different data sets, and then it would generate the report based on the training, and then it would give on these results to the doctors who would then review them, and the doctors would then make decisions upon the treatment. So after making the decision, the doctor then decides what type of treatment to give the patient, and then this data is then stored in the EHR, which is the health record of the patient. And then in the next slide, we are going to talk about the data and how we obtained it.
Now for the data, we've used 4 different categories, which is COVID-19, bacterial pneumonia, viral pneumonia, and Helena. So now we compiled all these classes together in order to provide a high quality image with metadatabase, also with patient age, gender, clinical diagnosis, to enhance the model staining accuracy. So now we obtained the labeled chest X-ray images from NIH institutions, and we also got the permission to use it in our data in our model, and we also ensured to give the patient confidentiality in the diagnosis. And now Aditya will be explaining the prototype.
So in order to build the basic AI prototype, we use certain AI tools. So first of all, we use TensorFlow, which is used to train our CNN model, and then we use Pandas to supervise and narrow the data, and then we use Seaborn for visualizing the class distribution and performance metrics to analyze it basically. So we also used additional AI tools, which I'm not going to talk about right now. And then we talked about the decision or the output of the AI model. So first it would do the disease classification, and then it would give confidence scores based on. So it would give confidence scores based on why it came to such a decision, and then it would explain on why it would give such a prediction, and then it would pass on that report to the doctor, who's then going to verify that report based on the help by the AI, and and then he would plan the specific treatment for the patient, and then he would give the patient the suited treatment, and the model updates, which would continuously train the model as the number of patients increase, the number of data increases, which would better the model in order to get better predictions and get better diagnostic accuracy. And now we are going to talk about the testing part, which Vian, my project manager, is going to explain.
So, who are the users who tested the prototype? Doctors and radiologists, medical students, and the healthcare administrators. So, the observations by the following people were for the doctors, they found very accurate and helpful for streamlining the diagnosis. And for the medical students, they found very easy to use since they already had a backhand knowledge of technology. And the healthcare administrators found it very promising but emphasized the need for seamless integration with the existing hospital management software. So taking these points into consideration, we've also made a user feedback grid. Now, after taking the feedback, we refined the prototype by simplifying the user interface, improving the explanations, adding more compatibility, and also the model to handle low quality data and expand the demographics, enable offline use, and also have a user guide with certain manuals. So the improvements we are planning to make later would be to incorporate multiple disease classification and also enable continuous learning by integrating live data for the model game. And other ones will be mobile integration, localization, expanding compatibility, more tools, performance optimization, and regulatory compliance. Now, Aditya will be explaining the collaboration.
So we worked on our AI project and we discussed this with the stakeholders. So basically we conducted regular meetings and we worked together to develop a fast and efficient working model. We engaged with the stakeholders who are the patients, the doctors and the hospital faculty, and we discussed with them, we found out the best ways to improve our model, took their feedback and then worked on our model in order to create a much more robust and efficient model. So we then move on to the individual learning reflection, which first will be done by Vian and then will be done by me.
Working on this project made me realize the importance of an efficient healthcare system in any nation. With these such solutions, we can help the doctors reduce their workload and also improve their efficiency and the time management. With these multiple points, we can also overall improve the quality of healthcare facilities of patients and also save patients from life-threatening diseases. Now, Aditya will be explaining about his self-reflection.
This project actually taught me a lot about the challenges faced by the data experts when they collect data and source it. They face a lot of challenges, whereas it might be regarding ethics or many other factors. I also came to learn how building a user-centered model can be very useful and how taking feedback and engaging stakeholders in the AI building process can be very, very helpful in bettering our AI model. And then now in the modern day, AI can be used in almost every domain and can be used to make everyone's life better. So in order to do this, our project is the biggest example. Our project can be revolutionary in the terms of medical field and to increase the doctor's diagnostic accuracy, which is going to go a long way in AI and humans partnership in making this world a better place.
So now this is our code and output. We've imported TensorFlow library and we've taken 4 data sets. This is our code and output. We've used 4 data sets and 4 classes, which I've already mentioned above. We put about 100 images for each and every class train and test accuracy of 98%, which is much higher and more efficient than doctors with overload work. Thank you.